In section 2.2, problem 57, we have a cube and a diagonal going down the center of the cube from corner to corner. And we need to find the dimensions of the box. So we need to start with what we know. So we have a 45 degree triangle down here on the base, because this is a cube, so that the base is actually a square. So that 45 triangle, this is a little isosceles triangle right here. We know that's a right angle. I'm thinking that this is the base of the box. There's a right angle here. And I know the sides are both x. So that gives me this triangle as an isosceles right triangle, which means that it is a 45 triangle, which is our special triangle, where the hypotenuse is the length of the leg times radical 2. So now I know, I'm going to draw an orange line. This orange line is this line right here in the cube. So now So now I'm going to pop out this triangle here with a theta. So that's the diagonal, that's 35 centimeters. And this is the side of the box, that's x. And this is the diagonal of the base. I'm going to do that line in orange so you can see that it's the same line as this. So that diagonal is x radical 2. And we got that from looking at the base of the rectangle, base of the cube. So now that I have this rectangle, that's my rectangle that goes down the center of the cube. Now I can use, I'm going to get blue. I can use Pythagorean theorem to solve for x to get the dimensions of the box. So I have x squared plus x radical 2 squared equals 35 squared, because this is a right triangle. So that gives me x squared. X radical 2 squared is x squared plus radical 2 squared, which is 2. And 35 squared is 1225. Combining my like terms, this is really x squared plus 2x squared. So that's 3x squared on the left. And on the right, I have the 1225. If I divide both sides by 3, I get x squared equals 408 1/3. Which, if I take the square root of that, I get and I can estimate with a calculator 20.2 centimeters, or I can do an exact answer of radical 408 1/3. This is the one you'll find in the back of your book. This is exact. Okay, since this is homework and you can use your calculator, I'm going to highlight this as our final answer. And also we have part B, which is to find that angle theta. So again, we're going to use this triangle. We have theta here. That makes the corner box. So I have the 3 sides, so I can, let's see. I know x is 20.2. And this x, 20.2 radical 2. So theta, I can use, let's do cosine. So cosine of theta is adjacent over opposite. So that's this guy. I'm sorry, adjacent over hypotenuse over this guy. So that's 20.2 radical 2 over 35. You know, I just realized we solved for x here in part A, but the question was actually find the dimensions. So for A, the dimensions are 20.2 by 20.2, and that is in centimeters. So that is actually my final answer. That's my answer for A. And then for part B, we need to solve this for theta. So to solve for theta, I need to get rid of cosine. So to get rid of the cosine and get theta by itself, I take cosine inverse of both sides. That's an exact answer. That's what I would expect on a test. But doing your homework, you can use your calculator and get a estimated answer of, on the left, the cosine inverse and the cosine cancel, and I just have theta. And on the right, I'm going to plug this into my calculator. To get to that cosine inverse, I need to toggle the shift key or the second key to get this cosine inverse with the -1. It comes up as a cosine, which means arc cosine, which is just another word for inverse cosine. And then in parentheses there I have the 20.2 times, go back to my toggle to get the square root sign, 2, close the square root sign, and then use the division sign for the fraction bar, divided by 35, and then close parentheses again for the whole. Notice from this parenthesis to this parenthesis I have what's inside the cosine. And what's in these two parentheses is what's under the square root. So then I hit enter and I get 35.3 degrees. Make sure your calculator is in degrees. You see in the top left here I have DEG. That means it's in degrees. If it says RAD, you need to hit this other button that toggles between radians and degrees. So you want your calculator in degrees to get that answer of 35.3 degrees.